Hello again, this is our Revox G36. I have here some schematics, and after servicing the motor on my previous video, I think it's time now to do some electrical services. The electrical services of this is just replacing some electrolytic capacitors that are old. Some people say that if something is working, don't touch it. And they say that by replacing these capacitors, these are axial capacitors, by the way, and nowadays we don't have axial capacitors. But some people say that, okay, maybe we do, but we don't find them easily. Anyway, so some people claim that if you replace the capacitors, the old capacitors, while they work normally, you compromise the authenticity of this for no special reason. I don't know what is correct and what is not correct, but I prefer to do it, to replace these capacitors. After all, this is my machine, so I do whatever I want with it, and I like doing stuff on it. That's why I'm gonna do it. So I have here I have written down here the capacitors that need to be replaced. It's 1, 2, 3, 4, 5, 6. These are the capacitors. So these two capacitors are on the output amplifier. We can see them here, one here and one here. It says 125. I don't know if other versions have 125, but I will replace this with 100. Let's see where they are. So these are under valve 10. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one capacitor is here and the other is back in there. These are the two capacitors that I'm gonna have to replace. This one is accessible, but the other one is on the back side, so I don't know how I will access that. There is a way to take all this out, just 1, 2, 3, you have to take out some valves and take 3 screws, I think, and then this comes out, not completely, but just a little bit to give you access on the back side of this. I will see if it's easy to do it. Next capacitor is the speaker amplifier C61. This is the speaker amplifier, and where is C61? There it is. Okay, this is somewhere between valve 7 and 8. 1, 2, 3, 4, 5, 6, 7, 8, and I guess, can you see it back there? It is there, that big gray thing back there. This is also on the back side, so I will have to somehow gain access to it. Next we have C36 and 38 on the VU amplifier. The VU amplifier is this part here, and it's 36 and 38. They are both under valve number 6. 1, 2, 3, 4, 5, 6. So one is here and the other is on the back in there. Okay, and the last capacitor we have to replace is the C68. It's the startup torque. Where is it? I think that here it is. This is what gives the startup torque of the take-up reel, and lasts for something like half a second and then goes to normal torque. And let me show you where this is. So this is a relay that controls the torque of this motor, and here at the back, can you see this capacitor here? There is another capacitor, the big one, in there. I will stop the video to light up the light of my phone to be able to see inside. Okay, now it's much better. There is a big capacitor here, which is the capacitor for the functioning of this motor. How do we call this? I forget. Working, not startup. It's not startup. It's working capacitor. Whatever, I don't remember. But there is another capacitor here, if you can see it here, which is that controls the time delay of this relay, and this also has to be replaced. It doesn't have to if it's working, but I think I will do it. I have gathered here all the capacitors I need, okay, and maybe a couple more, I don't know, but generally these are the capacitors I'm gonna need. And I will right now start doing this. So since I wanna get access to the back side of these extenders, I'm gonna have to take out some valves to reach some screws that are behind them. Okay, this is the first one. Okay, this is it. The others, I have to take out that one also. Okay, now I think I have access to all the screws here, which is one, it's here. This is with a straight screwdriver, but the other two, I think I got the wrong, it's supposed to be that one. Okay. So I have a cross screw here. Out. And I have another cross screw here. Okay. Now let's see how much movement we have. So that board gets on that board there, and these two capacitors are hard connected here, so I will bend them, but this is okay. The biggest problem is that this board is near that. No. So that board here is a little bit stressed, and I'm afraid is a red cable here. I got it out. Okay. So I think now I have enough access for all the capacitors I have to replace. So let me start doing it. Let me show you now that I have access from the back. That's how I am. For example, I will have to replace this capacitor here. I think I will cut the wire of this capacitor right on this contact here, and I will do the same on the other contact at the bottom, which is here. See? And I will solder both this wire and the new capacitor on this contact. That way it will be easier, because where this is soldered up here, I can barely see it. Now I put the phone in, but I cannot put in there any soldering iron or any hands or whatever. Okay. So the other capacitor here, here. Okay, this is this one, which is 50. This is also 50, and the other one is on the other side. And this one is a problem, and the other one is on the other side. So I will first replace these, which are at the back, and then I will put all this back and try to replace the other one on the. So now it's a big time, because it's time that I cut the old capacitors out. And now it's the worst part, where I am always afraid that I do something stupid and damage stuff. But anyway, since I decided to do it, one capacitor out. Second capacitor out. All of them are 150 microfarads. Oh, this one is put. Okay. 50 capacitors out. So these are the capacitors that I'm going to replace. Since nowadays we don't have axial capacitors that like this one, I decided to do that thing. So as I said, since we don't have axial capacitors now, I did this. I used some heat shrink to put the negative, no, the positive, to put the positive here on the other side with some heat shrinking tube right on the back, and I put some tape, this tape, and I put some heat shrink on the other side here, and I will use this instead of this. That's it. So just for the fun of it, I will check the old capacitors and see how they hold after all these years. So these are 100, this is 100 microfarads, 3 volts. and I have 100 microfarads, 25 volts. So this on the schematic is 125, but the actual capacitor is 100 microfarads, so I will replace with 100 and I will be okay. So this says 100, but it is 125. ESR 6.9. My replacement is 100, but ESR is 0.63. So instead of 6 ohms ESR, I have 0.6, 10 times less. So my new capacitor will be much better. Let's check the 50 microfarads capacitor. The 50 microfarads capacitor is 138. It's well out of specs, and there should be another 50, which is here. (108), but 1.91 ohms. Let's 100. That should be 50, and it's 100. Generally, all capacitors seem to have lost a lot, or so it's not bad at all that I am replacing them. So now I will start soldering. So I did something stupid before, because I didn't leave some of the old legs in there, and that wasn't all enough. So I had to add a little bit here. Anyway, so now it's time that I start soldering. This is where I have to be careful now. Clean my soldering iron. And now I should prepare the 50 microfarads. So this is 50 microfarads. And where is my 50 microfarads? Hundred 47. So 47 microfarads instead of 50, 20 volts, 25 volts I'm putting. Just a quick test. (51) 0.9 ohms. Perfectly okay. So I will bend the positive side, which is longer. I will bend it upwards, and I will put some heat shrinking, just like that. And then I will cover both these with some tape. Okay. And then I will use a small piece for the negative lead that goes downwards. Okay. The negative lead here, as I was trying to put it, it went down and fell. Maybe I will use this like that also. Let me see. Yeah. What happens to me all the time? I'm looking for my stuff. So, I will now add some solder there. So, I'm done with the 3 capacitors that were at the back. Now I will show you how it looks like. So I replaced one capacitor there, this one, and this one, all of them negative side faces to the bottom. Okay, in case you forget how it is. Now I had lifted that a little bit, I will put it back there, and now I will put this back and do the front ones. Okay, good chance to clean some dust here. The tubes, they look like they have stuff on them. But I am really a little bit afraid to mess with them too much. But anyway, so let's put back that thing here very carefully on this area here, not to damage something. And there is a notch here and a notch here also on the other side. And then I think I'm gonna have to lift. Yeah. Okay, you have to lift it like that a little bit so that the two holes align, and the other one here. This cannot align that easily. Why? What? Something is holding it back. But eventually it will, just like that. this happens. Stopping the video. So, as you know, when screws fall down on you, they become ghosts and then they get legs and they go far away and you nearly can't find them. Eventually, I found this screw and I got a big screwdriver where the screw can stick at the front so that I don't have to worry too much. And just like that, I can put that screw back in. So this is done. Oh, there is another screw that I have to put. This is easier because the other two screws aligned that part with the back. So now it's time. Let's see if that light makes it difficult. It does. Okay. That's easier now. Okay. Okay, so now it's time. Okay, it's time that I take out the capacitors at the front. So it's one capacitor here. This is the 100 microfarads. Let me put these ones away. And the other capacitor is here. Which is 50 microfarads. Let me test them and see their actual condition. microfarads, 4.0 ohms. Capacitance is nearly okay, but ESR is bad. This one. 91 microfarads instead of 50, 1.28 ohms. So my 100 microfarad capacitor (105 microfarad), 0.6 ohms, and 47, which is well, it seems I miss a 47 capacitor, so I will go and find one now. So I did find a 47 microfarads capacitor. It's a good thing I have a lot of components as a stock around, because I don't have, each time I missed something, to go out and buy, or even worse, wait until somebody, some shop around brings it, because not all components are readily available. So this is the capacitor that has to go somewhere like that. I will try to secure it in place with as much solder as it is now on my. So all the audio part of this machine is done. It's one capacitor here, another capacitor there at the back, this is for the output amplifier, one capacitor back there for the power amplifier, one capacitor here for the VU meters, and another one at the back there for the VU meters. 4 capacitors for the audio part of this machine. Now I will test it. So, audio part of this machine is done, and so VU meters are working, audio part is working, both channels. So I didn't check the output amplifier. Let me stop it. I have to check if the output amplifier is also working, but I have cut out the wires for the external speakers, so I cannot check it right now. But maybe I will put some other speaker and see if it works, but I don't see that there will be any problem. So audio part is done, and there is one more capacitor to replace, which is this one here, as I showed at the beginning of the video. I think that taking out this will make all that thing go out, so that I gain access to all this stuff back there, and I will try now the. So I will need some pliers. There we are, to take out that nut, which is rather hard. Another bigger pliers. No. I wonder why they. It's really hard. I will bring. Maybe that would fit. No, it doesn't. I will bring another tool to take this out. So with this tool, it will definitely go out. Okay, I heard something. Okay. Nut is out. And okay. So this is the capacitor of the motor. Okay. And this is the capacitor I will have to replace. 250 33 volts. I have 220 63 volts. It's more than enough. So it's time to replace it. Where is negative? It doesn't show. Where is the negative? Where is the negative? Okay. So this side is positive, this side is negative. I will check it, just 1 minute, I will check it with the service manual to be absolutely sure about that. So as I said, this side is negative, but I will check it with a multimeter. If it is indeed sorted to ground, it should. There we are. So this side here is sorted to ground. So this side is negative. Soldering iron, and let's start. I will stop the video until my soldering iron gets hot. Well, my soldering iron is hot. This is really hard soldered there through the hole. So I think I will cut it. Where's my pliers? But I don't find my pliers. There it is. So I will cut it and pull out afterwards. Now I will pull out a bit here. See? On the other side I think can stay as it is, no problem. And it's time to put the capacitor. I can solder it as it stands there right now. It makes it hard for me. I have to do this because okay, this capacitor is also done. Let me cut the extending leads. The other side here. And I forgot to measure this capacitor, but I think it's okay to measure it on board. It shows in circuit. Yeah, it runs through the motor and comes back. Okay, I didn't measure it before as I should. I hope that won't be a problem. Let's see the old capacitor. $275, 0.58 ohms. Actually, this capacitor is not in bad shape at all. I could even keep it just for the fun of it. But anyway, let's put everything back. this goes like that. The motor capacitor goes through the hole there and out to the front, which is supposed to be there. Just put the nut a little bit. Okay. And that's how it should be. I will just put a little bit more force on that. Okay. So I guess this is also sorted out. This is also sorted out. And let's see if we have that increased startup torque. So there we are. Have a look at that part here as I turn on play. You see, after about half a second, it changes state, this relay, after half a second. So it works, it is successful. So I have recapped this thing. Now I will start listening to some music from it and proceed with some other improvements, repairs or whatever in the future.